In this video, I will try to help you understand a variety of technical education opportunities available here at BYU Idaho, with the hope that it will help you in deciding your course of study. Here is a quote from President Hinckley to set the stage. "The Lord wants you to educate your minds and hands, whatever your chosen field." We all know that some fields of work require more training of the mind, and some require more training of the hands. I like to think of technical education as being a continuum. Programs toward the left are more focused on training the mind, while programs toward the right are more focused on training the hands. Perhaps the word theory is a good word to use when thinking about training the mind. And developing skills is a good way to summarize what is meant by training the hands. Examples of programs that lie to the left in this area are physical sciences, like physics, chemistry, or geology. Let's say, for simplicity's sake, that an average physics program contains about 80% theory-based training and about 20% practical skills kind of training. Further to the right, we find technology programs, which are much more focused on developing practical skills, perhaps only 20% theory and 80% skills. This area on the left side of center describes traditional engineering disciplines, where there is a significant amount of theory, but definitely a strong focus on application, perhaps 60% theory and 40% application and skill-based training. That leaves a large gap in this area. Are there educational programs that fit in this area? Yes, there are. Perhaps these programs are not as well known by incoming freshmen, but they provide very marketable careers. Engineering technology programs are specifically designed to fill the needs of this area. These programs contain more hands-on training than traditional engineering programs, but still retain a decent amount of theory, perhaps 40% theory and 60% skill-based training. We often hear people refer to careers in this area as blue-collar or vocational employment, and careers in this area are often referred to as white-collar employment. Perhaps what is more important than what others call them is what they call themselves. Individuals with this type of training call themselves scientists. People with training in this area call themselves engineers. People with training in this area call themselves engineering technologists. And people with training in this area call themselves technicians. ABET is the National Accrediting Board for Engineering and Technology Programs. Here is a quote from the ABET website. "Graduates from engineering programs are called engineers. Graduates of four-year engineering technology programs are called technologists, while graduates of two-year technology programs are called technicians." It might be helpful to discuss some generalities of what individuals who work in these areas do. Scientists are very interested in the process of discovery and are continually trying to better understand physical laws and phenomenon. Engineers are interested in applying this understanding in beneficial ways. They are often involved in synthesizing, designing, analyzing, and optimizing. Technologists focus their efforts toward implementation. They often work with engineers and help facilitate testing and manufacturing. Technicians are often involved in installation, maintenance, and operation of equipment and facilities. Another good way to gain insights into these disciplines is to understand the level of math required for entry-level positions. Technology programs usually only require basic math skills such as arithmetic, basic algebra, and geometry. Engineering technology programs go beyond basic math and require college algebra, trigonometry, calculus, and statistics. Engineering programs not only require basic math, college algebra, trigonometry, and calculus, but also require students to continue on and study multivariable calculus, linear algebra, and differential equations. Engineering programs also require a course in statistics. Physical science programs usually have very similar math requirements as engineering programs. Let me clarify these math requirements by showing course numbers associated with BYU Idaho. Technology programs here usually only require the Foundation Math 108 class. The engineering technology programs require Math 109, called Pre-Calculus, which contains both college algebra and basic trigonometry, Math 112, which is basic calculus, and Math 330, which is engineering statistics. The engineering programs at BYU Idaho require Math 109, Pre-Calculus, Math 112, basic calculus, and Math 215 and 316, which cover the topics of multivariable calculus, linear algebra, and differential equations. Math 330, Engineering Statistics, is also required. Some students coming to BYU Idaho and desiring to study engineering have already had AP Calculus in high school, which means they only have 3 math classes to take. Some students did not have calculus in high school but completed pre-calculus. They would need to take these 4 math classes. Those who didn't have a strong pre-calculus class in high school will need to take all 5 of these math classes. The physical science programs at BYU Idaho have the same math requirement as engineering, except some of them do not require statistics. Now I would like to show you the degrees that are available at BYU Idaho in these areas. In the physical sciences area, we offer a 4-year Bachelor of Science degree in physics, chemistry, and geology. In engineering, we offer BS degrees in civil engineering, computer engineering, electrical engineering, and mechanical engineering. In the engineering technology area, we offer a BS degree in automotive engineering technology, a BS degree in manufacturing and supply chain, a BS degree in welding engineering technology. Technology degrees at BYU Idaho include a 2-year Applied Associate degree in automotive technology, a 4-year BS degree in automotive technology management, a 2-year AAS degree in welding and fabrication technology, and a 4-year BS degree in welding and fabrication technology management. We also offer a 4-year BS degree in Advanced Vehicle Systems, which probably fits right here in the overlap between automotive engineering technology and automotive technology. Now let's look at a few specific scenarios. What are your options at BYU Idaho if you are really interested in the automotive industry? You could choose the 4-year BS degree in Automotive Technology Management. You could choose the bachelor's degree in Advanced Vehicle Systems. You could choose the bachelor's degree in Automotive Engineering Technology, or you could choose the bachelor's degree in Mechanical Engineering with an automotive emphasis. Each of these are wonderful options, but each would lead to different types of jobs in the automotive industry. What are your options at BYU Idaho if you are interested in the welding industry? You could choose the bachelor's degree in Welding and Fabrication Technology Management. You could choose a BS degree in Welding Engineering Technology, or you could choose a BS degree in Mechanical Engineering with a welding emphasis. Each of these are great options, and each will lead to different types of jobs in the welding industry. What are your options if you are interested in the manufacturing industry? You could choose the BS degree in Manufacturing and Supply Chain, or you could choose the BS degree in Mechanical Engineering with either a manufacturing or a supply chain emphasis. These are all great options that would lead to different types of jobs in manufacturing. I hope that you are noticing that each of these areas is pretty broad and can accommodate a variety of interests. One physicist may be very focused on discovering and formulating underlying theories, while another may be more interested in application, modeling, and simulation. I know engineers who really enjoy developing computer tools to mathematically model and simulate complex systems to help in design optimization. I know other engineers who prefer to be out in the factory designing and implementing manufacturing tooling. It's not uncommon to see one engineering technologist involved in testing, instrumentation, and validation, and to see another technologist installing or repairing high-tech equipment. Technicians can be equally as diverse. Some prefer to be helping develop new advanced welding processes, while others are true craftsmen. It is also important to see that these areas have significant overlap. Perhaps your interests are in this area. You could find satisfaction as a physics major or an engineering major. What if your interests lie here? You could be successful as an engineer or as an engineering technologist. What if this is you? You could be happy as a technologist or a technician. I would advise you to give some thought to where your interests and aptitude lie. I feel like this is where I fit. I enjoy math and physics, I love designing and inventing, and I love being out in the shop building stuff. Mechanical engineering was an obvious choice for me, and is turning out to be a very satisfying career. I wish all of you the Lord's blessing in making a wise career choice, something that will fit your aptitude and interest. And I know that if you live worthy of the Holy Ghost, you will be guided in this important choice.